All right, so based on the work that you've done in class, we're now at a point where you are ready to do these problems. Now, my assumption is you started these problems in class, but I know that many of you have not, and what I've realized is I need a way to hold you accountable for the work that you've done in class. So if you spend time chit-chatting instead of doing the work, all that's going to happen is you're just going to find that there's this tremendously painful amount of homework in physics class that just never goes away. And if you're actually staying on focus in class and you're doing the work and you're not chit-chatting about your social life, but you're actually staying focused on what we need to do, what you'll find is that homework ends up being a very easy thing because you've gone through these problems and all you have to do is enter the answers into the Google Doc. So the goal is to stay focused and work quickly. So we're going to jump in and take a look at these problems. I'm going to tell you right now, this is going to be what I call a partial solution set. And the word partial solution set, of course, is code for very disappointing to you as a student. So let me explain. We have a projectile shot into the air, and it's going to go up to a height of 8 meters. So what we're going to say is y is 80 meters here. And then, of course, we have a y naught equal to 0 meters that we start at. Now, we have the initial velocity, which we want to determine, but that's an unknown. And, of course, here at the top of a projectile's trajectory, we remember this from the last unit, from unit 2, that's 0. And, of course, remember that ay, the acceleration in the y direction, that's just negative g, which is negative 9.8 meters per second squared. Now, with this in mind, you look at this setup, or I look at this setup, and my immediate thought is, well, this is actually the stuff that we covered in Unit 2 for Exam 2. And therefore, as far as I'm concerned, this topic is a review. So in my mind, this is something that you're fluent at, and therefore I'm going to stop working this problem here. And if you look to the right on this YouTube video, if you're on my website, this is actually Google Form problem number 1, immediately to the right of this video on the website. Similarly here for problem number 2, we have a projectile. It's fired from the ground straight up, and if you look, this picture is almost identical to the picture we have in problem 1. And if you notice in problem 1 here, we actually didn't have the time, nor do I actually ask you for it. It is something that I believe it's in your power to solve for. And I may actually hold you to that on a quiz later on if I haven't made one up. Or just, you should know how to get this time. And if I were you, I would just kind of do that calculation and have it around, just because you never know when it's going to pop up again. My expectation is, whether I ask you about it or not, you should be able to do it. Okay, so I'm kind of appealing to your greater conscience here. So if you can't do that calculation, even if I never ask you to calculate this time in number 1, you should feel a vague sense of unease if you're unable to do that calculation, because it is exactly the kind of the thing that you are accountable for, even if I don't specifically ask you to do that question now. So we have this initial velocity that is in fact unknown. We know the velocity at the top of the trajectory is 0 meters per second. And we know that the acceleration in the y direction is, of course, negative g, which is negative 9.8 meters per second squared. We are given a time here of 10.2 seconds. Once again, if I had to say this again, I would highlight all of this here. And I just let you know that all of this is review. It's as far as I'm concerned, this is exactly the kind of thing that you would do for your exam number 2. And so this is going to be Google Form question number 2. Okay. Similarly here, and the difference between question 3 and question 2 is you're going to fire the projectile straight up into the air, and then it's going to return back down to the ground. So again, we have the same trick with the hang time. We're told that we have the total time of 2 seconds. So you can talk about the time going up or the time going down. This is the total hang time. That'll be the one little hint that I give you here. And you should know what to do with when you have the total hang time. You should be able to adjust that time or do something mathematical to that time, or however you want to say it, to get this problem right and determine the initial velocity of the object. So once again, the same idea. And this is going to be Google form number 3. And it's not that I'm trying to punish you here. It's just we've got a certain level of expectation now that with these hints are for people that don't feel 100% comfortable. Realistically, what I really expect is questions 1, 2, and 3. Maybe you don't even, in my mind, you shouldn't even need to watch the videos to get these answers. These are just hints for people that feel like they're a little bit rusty. And so if you're looking at these hints and you're in a place where you say, I have no idea what's being talked about right now, you need to change your plan of how you're managing your time. And you need to get on a new plan for your time that involves you interacting with me a lot more, like in class, after school, etc. And if that's not possible, then you may need to seek outside help and get some kind of a tutor. Okay. I will say, though, I'm here many hours after school. So for this problem here, so this is a Google question number 1, number 2. Right here, when I look at question number 4 in this sheet, this is going to be Google Doc, numbers 4, 5, and 6. So my expectation is you're going to be practicing these to the point that you're just going to get faster and faster and faster. Okay. Now, we finally move on to the new parts of what we're doing. And when we move to question number 5, and I'm just going to say this right now, the answers here, this is going to be Google Doc, number, I think it should be number 7. Yep, number 7, number 8, and number 9. We're now finally into the new stuff. Let me explain what's going on. We're going to have this football, and it's punted. I'm going to really exaggerate this angle at an angle of 5 degrees. And of course, we have an initial velocity of 15 meters per second. And again, at this point here, this is my expectation. My expectation is that you showed up to class and you were diligent and you did your work and did the derivation and sweated all over all of that. You climbed that hill and you're like, oh, I'm finally done. Is it over? No, it is not over. We have, when you climb that hill in physics, you're expected then to kind of look to the next hill. And so now your goal is you've derived this equation, you've had me help you with this equation. Now your goal is to use what you did here and what you did here, especially here, to apply it to this new problem here. So what you're going to do is I expect you to turn in your learning packet to this whole set of calculations you did here and use a similar approach to solve the problem here. Now, if you're doing this passively, what you'll do is you'll just simply follow every single step here and just passively go through everything and then passively repeat the identical process here and just solve the problem mechanically. If you're actually thinking about, is there stuff here that he repeats? Does this relate to previous information I've learned before? You will notice that the amount of work you did here, on these pages and pages of work, versus the amount of work you do here actually gets shortened. So I'm expecting you to use this here as a guide, not as a literal step-by-step instruction manual. Now, if you need to do that the first time, that's great. But for the exam, if you actually try to use this as a literal guide that takes you step by step through problems slowly, you're never going to get the exam done. So you're expected to practice with this so that this process becomes shortened in your mind because you're getting faster at it through practice. So this one problem is designed to give you some practice. So you're going to go ahead and solve it on the Google Doc. And then when you come to class on Friday, we're going to actually generalize this idea even further. And that takes us to question number 6 here. I haven't decided whether we're doing this Friday or whether we're doing this Monday. But what we're going to be doing is I'm going to have you, you're going to love this, you're going to solve this problem by hand on Friday. So in other words, you have problem number 5, and the angles change, so you're going to have 15 meters per second, and you're going to look at this here, and you're going to solve it for 10 degrees. And then you're going to do this and solve it. And then you're going to go ahead and you're going to do the same problem again, and now you're going to have 20 degrees here for the same speed. And you're going to notice that you get all this practice in solving the problem quickly. And it's going to get very repetitive. And let me just be very clear on this. I think you need to say whatever acceptance prayer you need to say around this. you're doing this, and this, and this, and this, and this, and this, and this. I actually have a reason for doing this, and it's kind of mean, but here's the reason. I want to cause you a little bit of numerical pain so that you reach a point of desperation where you say, is there a better way of doing the problem than this? And the answer is yes, and this is what I want to lead us to. What I want to get us to is, I want to give you a general launching velocity v0 and a general angle theta. And your goal will be to come up with a general formula for, and let's just get these numbers, for the hang time, and I'll just call it T hang, for this letter called x final, which is the total, so you launch it at this v0 at an angle theta, and of course it flies in the air, and it lands at this x final, and of course we reach some y final, maximum height here, and for the y final, the maximum height. So I want you to get these things entirely in terms of letters, v0, theta, and g, the gravity. And what will then happen is this problem here becomes way, way, way easier to do because I just give you v0 equals 5 and the angle equals 10 degrees, and you can actually plug that into formulas that you put into your calculator or into Excel, which we'll talk about later, and get an answer. And then when you need to get the next thing, you can actually plug in another number. And then what I'm going to actually end up doing here is, and this is going to be actually the best part of this, is I'm going to teach you how to use a spreadsheet so that you can actually click and drag formulas. And when you actually do it that way, you will see a real practical reason for why do teachers make us use so many letters in physics. Because this is probably going to take you about 75 minutes. This, when you have a formula that you've come up with, it'll take you maybe 10, 15 minutes to come up with a formula. And when you actually do the calculations with the formula, it will literally take you, after you solve for one angle here, it will literally take you less than 5 seconds to get the rest of these. So we're going to compare those two methods to kind of give you a motivation for coming up with derivations on your own. So that'll be what we do on the third day of class. So that'll get you set up. So have fun. Good luck.